In the beginning, there was darkness, and then, bang, giving birth to an endless expanding existence of time, space, and matter. Now see further than we've ever imagined, beyond the limits of our existence, in a place we call the universe. Our sun is one of billions of stars in the Milky Way galaxy. And our galaxy is one of hundreds of billions, maybe a trillion, in the known universe. From the Hubble Space Telescope comes a view of the universe that was. A magnificent trip through the mists of history, and back nearly all the way to the Big Bang. Each smudge, each clump, each blob of light. A billion stars here, a trillion stars there. If you want to know our place in the universe, take a look up and far, far away to the realm of alien galaxies. Ours is a universe of motion, expansion, light, and blackness.
We think the universe is about 13.6 billion years old. So just to put that in context, the Earth and the solar system is just over 4 billion years old. So the universe is just over 3 times older than the Earth.
Across the vast reaches of the interstellar void, distant stars are held together by the long reach of gravity's unyielding grip. Over billions of years, these stars have come together to form galaxies.
A galaxy is a collection of 100 billion or so stars. And these stars are by no means touching each other or actually anywhere near each other compared to their sizes. They're very, very far apart from one another.
The thing that blows my mind about galaxies is what monsters they are. They are incredibly huge. If the sun were the size of a period on a page, of the dot of an eye, our galaxy would be the size of the continental United States. So they're gigantic.
Astronomers have always known there was something special about the band of stars and dust that seemed to encircle the night sky above them. It's our galaxy, a white smudge they called the Milky Way.
That band of light is the collected light of hundreds of thousands of stars that you can't see individually with your eye. And that was named by the Greeks. They thought it looked like a milky river, so they called it the Milky Way.
There are 100 billion stars in our galaxy, and there are 100 billion galaxies in the observable universe. That's more stars in the universe than grains of sand on the beaches of the Earth.
Imagine a galaxy itself is the size of a hockey puck. Then the galaxies are spaced from one to another about a few diameters apart. So if there's a puck here and a puck over there, that's kind of the way that galaxies are spaced in the universe.
Pictures
from the Hubble Space Telescope show the wide variety of alien galaxies. The Sombrero Galaxy, also known as M104. One of the most massive objects in a gigantic cluster of galaxies, the Sombrero Galaxy contains nearly 800 billion times as much mass as our Sun. Compared to the Milky Way, Sombrero has a much larger bulge relative to its highly wound disk. This image of the Sombrero Galaxy is also a prime example of what happens when 3 of the world's top space telescopes join forces. The Chandra X-ray Observatory, taking an image of the high-powered X-rays emitted by the Sombrero Galaxy. The Hubble Space Telescope, snapping an optical picture, capturing the visual light that's made the multi-million light-year journey to Earth. And the Spitzer Space Telescope, capturing an infrared version, looking at the Sombrero Galaxy's heat signature. Melded together, these 3 images provide a stunning and unforgettable look at a galaxy 28 million light-years away. M51, the Whirlpool Galaxy. Its spiral arms twisting like cotton candy being spun. The center of the Whirlpool Galaxy is so densely packed with stars, anyone living on planets there would be under a constant bright sky, day or night. Centaurus A, a galaxy sending out massive amounts of radio waves. Think of it as an interstellar broadcaster, beaming its signal throughout the universe all day, every day. It's the closest of the so-called active galaxies, galaxies that pour out tremendous amounts of energy from their cores. This is the Hubble Ultra Deep Field image. Created using the Hubble Space Telescope, it shows us how truly vast and distant the universe really is, and how those far-off spaces are anything but empty.
When you look very deep in the universe, you're looking back in time. So you're looking back at galaxies right back to when they were very, very young, when they were only a few percent of their current age. So the Hubble Ultra Deep Field is really like a time tunnel that gives us a glimpse of galaxies as they were before the Earth was in existence. The Earth is 4 billion years old. We're seeing galaxies as they were 13 billion years old. So the light left these objects before there was any Earth at all.
The nearest large galaxy to ours, the Andromeda Galaxy, is about 2 million light years away. So the light from the Andromeda Galaxy takes 2 million years to get here. So we're seeing it as it looked 2 million years ago. And that's one of the more nearby galaxies. As we look farther and farther out in space, then we're looking farther and farther back in time.
To get a better idea of the concept, just visit one of the most spectacular vistas on Earth, the majestic Grand Canyon.
As you look down the layers, you get older and older rocks, and we can tell what the different environments were. So we can actually look at the geologic history of this area over time, and in essence look back through the environment that was located right here, back over hundreds of millions of years of the Earth's history. So by looking at stars that are further and further away from the Earth, astronomers can get an idea of the evolution of the universe.
From the earliest days of galactic astronomy, observers noticed galaxies came in a variety of shapes and sizes.
The two main types of galaxies are spiral galaxies, like our Milky Way, which have spiral arms in a thin disk, and then elliptical galaxies, which are sort of more spherically or elliptically shaped, and they don't have spiral arms. The spiral galaxies have a lot of gas and dust in them, from which new stars are forming right now. Whereas the elliptical galaxies seem to have formed their stars long ago. They don't have that much gas and dust, so they're not forming stars right now. There's also some irregular galaxies, which generally have a lot of gas and dust, but not in a nice spiral form.
Detecting these far-off accumulations of stars is made easier when astronomers search for the streaming, blasting beacons found near the center of many of them. Violent and erratic hearts beat at the center of many alien galaxies, sending out so much energy they can overwhelm the amount of energy produced by all of the other stars within them. These are the active galactic nuclei.
So we can look at some galaxies and we find that they have at their very centers very powerful engines that are producing a tremendous amount of light. We can tell that they're very far away, and yet they're still very bright when we look at them. So they must be tremendously powerful, dumping a lot of energy out every second.
Among the most violent and powerful of the active galactic nuclei, the mysterious phenomenon called quasars.
When we look at quasars, quasi-stellar objects, and see how far away they are, some of them are tremendously bright. The brightest one of them is about 1 trillion times as bright as our sun.
Spectacular streams of electromagnetic energy, bright beacons lighting up the sky for billions of miles. These high-energy sources provide a stunning reminder of the universe's power to illuminate.
A quasar itself can be brighter than an entire galaxy. So when we look at a quasar like 3C273, the Hubble Space Telescope took some images of this, and we found that it has a big jet of material shooting out of the side of it, almost the size of the galaxy itself.
These are really weird things, these active galactic nuclei.
As active galactic nuclei show, space is a violent place. And as it turns out, there's a massive collision going on. Right in our own backyard. The culprit? A galaxy called the Canis Major Dwarf Galaxy. As the name implies, dwarf galaxies are small, making them even more difficult to detect. Now, the Canis Major Dwarf Galaxy is taking aim at the Milky Way. Two galaxies on a collision course from which, thanks to gravity, there is no escape.
When a small galaxy comes too close to a large galaxy, the tidal effects cause it to be stretched out and distorted. So the gravitational attraction of the larger galaxy will actually pull and stretch the stars in the smaller galaxy. So a collection of galaxies that has a relative spacing compared to their size, about like the way these pucks are laid out on the ice. All these galaxies would be moving through space with respect to one another. But every once in a while, one of these galaxies is going to bonk into another one. Now, when that happens, the shape of the galaxies would actually become distorted and stretched out. Pucks are solid. Galaxies are made of individual stars, each of which feels the gravity of all the others, and they become distorted and torn into tidal tails, a big swooping arc of stars in either direction.
And that's how the once far-off stars from an alien galaxy, blazing through space for millions upon billions of miles, can end up blending right in with our own. But what caused these stars to clump together in galaxies? Why has the matter and mass of the universe fused into these spectacular structures? To find the answer, we have to turn our clocks back millions and billions of years ago. Go back far enough, and you reach a point where all the matter and space and time become compressed and compacted into an infinitely small point, a gravitational singularity of infinite dimension. It's a point that exploded with a spectacular Big Bang. A long time ago, the matter and energy that would make up every alien galaxy wasn't far away. Everything that ever became an alien galaxy sprung forth from a gravitational singularity that has come to be known as the Big Bang.
If you run a film of the universe backwards in your mind, eventually you get to a point where the density would become extremely high. If you go far enough, all the mass and energy that we have in the universe would be in a single location, and you would find infinite density. We think that the expansion of the universe is telling us something very profound, that the universe has a beginning point in time.
In those moments after the Big Bang, the rules of our universe and stars took shape. And one of the biggest rules was the law of gravity.
After the Big Bang, the universe, of course, was expanding. But there were some parts that were denser than others. Those denser parts started gravitationally contracting, and they formed galaxies. Pockets of gas within those gravitationally contracting clouds formed stars, because those pockets gravitationally contracted even more than the general cloud of gas.
It would take hundreds of millions of years for the first galaxy to coalesce into existence.
We don't know exactly when this happened, but we can see pretty mature galaxies about 1 billion years after the Big Bang, and the earliest objects that I can see are about 500 million years after the Big Bang. So it's within this period that we think the very earliest objects switched on. But we haven't yet found a time when there were no galaxies at all.
To learn more about alien galaxies, we need to solve the many mysteries of our Milky Way's own place in the universe.
when we want to look at the structure of our galaxy, the difficulty that we run into is that we're inside of it. We can only see what we can see from inside. Moreover, there's dust and gas blocking our lines of sight, so we can't see very far from our position in our galaxy in many different directions.
We think the Milky Way is a barred spiral galaxy reaching about 100,000 light-years across, with a 3,000 light-year thick core. Most galaxies in the universe are smaller. The Milky Way and many alien galaxies are like cities with a central dense core and less dense suburbs. For spiral galaxies like our own Milky Way, that means a trip to visit the burbs is not unlike a trip on the freeways.